Hi dear students of plus 2 medical and non-medical. First of all, welcome you all on my YouTube channel Physics Concepts and Motivational Talks. And today's topic is very interesting and very important. We have to find electric field due to a dipole at a point on axial line and at a point on equatorial line. So first at a point on axial line. Now suppose AB be the dipole having minus q charge at point A plus q charge at point B. Let 2L is equal to length of the dipole. So that OA is equal to L and OB is equal to L. Let OX be the axial line of the electric dipole. Let a point P on the axial line at a distance is equal to R from the center of the dipole. So that OP is equal to R. OP is equal to R. Where we have to find electric field due to this dipole AB. So let a plus 1 coulomb charge at point P, where electric field due to dipole is to be determined. Since every charge plus q and minus q will experience force on test charge plus 1 coulomb. Therefore, in other words, we can say that there will be electric field due to charge at B as well as due to charge at A. Let EB be the electric field at plus 1 coulomb charge, that is point P, due to charge at B. Then EB will act along PX. Similarly, let EA is equal to electric field due to charge at A, that is minus q charge at point P, which will act along PB. So EA and EB are the two electric fields due to separate charges plus q and minus q, and they are opposite. Moreover, EB magnitude will be greater than EA magnitude, because point B lies close to P than point A. So electric field is inversely proportional to distance square. So therefore, EB magnitude will be greater than EA magnitude. Therefore, resultant electric field at point P, that is a point on the axial line of the dipole AB, will be equal to EB plus EA in vector form. This EB plus EA. Now since EB and EA are opposite, and moreover EB magnitude is greater than EA magnitude, therefore E is equal to EB minus EA. EB minus, and or E is equal to 1 upon 4 pi epsilon naught electric field due to charge at B on point P, 1 upon 4 pi epsilon charge over distance square, that is q upon BP square, minus EA 1 upon 4 pi epsilon naught q upon AP square, or E is equal to, q is common, 1 upon 4 pi epsilon naught is common, so 1 of BP square. So BP square means OP minus OB, that is R minus L. From the figure very clear, it is 1 upon R minus L whole square, minus 1 upon what is AP? AP is R plus L. So R plus L whole square. Or simplifying, we get E is equal to q upon 4 pi epsilon naught R plus L whole square minus R minus L whole square over R square minus L square whole square. So A plus B whole square minus A minus C whole square is equal to 4AB. So E comes out to be 1 over 4 pi epsilon naught. This is 4ab means r plus l whole square minus r minus l whole square is equal to 4rl. So it will be q into 4rl over r square minus l square whole square. Now we have proved P is equal to Q into 2L. If P is the dipole moment of the electric dipole, so then 2QL is written as P. So it comes out to be 1 upon 4 pi epsilon naught 2PR over R square minus L square whole square. So which is the required expression for electric field due to a dipole at a point on the axial line. So 1 upon 4 pi epsilon naught 2PR where P is equal to Q into 2L. So Q, L or 2 from here is E, so it is remains only 2PR. So P is dipole moment. L is the half the length of the dipole. R distance of the point from center of dipole. And 1 upon 4 pi epsilon naught is constant. In SI systems value is 9 into 10 raised by 9 SI units. So it means if we have a short dipole, for a short dipole, L square is less than R square. For short dipole, L square is less than R square. That is, L is very small when point is far away from the center of dipole. So dipole is a very small length, short length. Then L square can be neglected as compared to R square. So we have E is equal to 1 upon 4 pi epsilon naught 1 upon 4 pi epsilon naught 2 PR upon R4 2 PR upon R power 4 2 PR upon R power 4, or in other words we can say that E comes out to be E is equal to 1 R cancels, so 1 upon 4 pi epsilon naught 2p upon R cube 2p upon R cube. So this gives the electric field due to dipole at a point on the axial line. 1 upon 4 pi epsilon naught 2p upon R cube simply. When length of dipole is very small as compared to distance of the point, that is for a short dipole, electric field you can see is inversely proportional to R cube. So we proved electric field is inversely proportional to R cube. It is electric field to dipole is inversely proportional to cube of the distance from the center of dipole, and for a single point charge electric field is inversely proportional to R square. It means electric field due to dipole decreases more rapidly as compared to electric field due to single point charge. So this is electric field due to dipole at a point on axial line. I repeat, simply you have to take dipole AB, let P be any point on the axial line, put plus 1 coulomb charge at point P, let OP is equal to R, then EB will be electric field at P due to charge at B, EA electric field at P due to charge at A. So EB and EA are opposite. Moreover, EB is greater than EA because point B lies close to P than point A. So net field will be EB minus EA. And by definition of single point charge, electric field single point charge 1 upon 4 pi epsilon naught charge over distance square. VP square AP square. So VP is R minus L, AP is R plus L. Simplifying A plus B whole square minus A minus B whole square 4AB, and 2 into QL is equal to P, that is dipole moment. So this gives expression of our electric field due to a dipole at a point on axial line. Next, now electric field due to dipole at a point on equatorial line. So let again AB be the dipole, minus Q charge at A plus Q charge at B. Let O by be the equatorial line, that is a perpendicular bisector of the dipole. A line passing through center of dipole and perpendicular to the length of dipole is called equatorial line. Let P be any point on the equatorial line where electric field due to dipole is to be determined. Join AP, join BP. This OA is equal to OB is equal to L. Let OP is equal to R, same distance of point from the center of the dipole on equatorial line is R. Then this BP and AP will be equal to under root R square plus L square, square root by Pythagoras theorem. Suppose this angle is theta. Now put plus 1 coulomb charge at P, because we have to calculate electric field at P. Then electric field at P due to B will be in this direction, because it is positive, so it will be in this direction. And electric field at P due to charge at A will be along PA. This is EA. It means EB is acting along BP and EA is acting along PA. So these two electric fields EB and EA. In this case, electric field EB and EA were opposite, but in this case they are inclined. Now, by using Prof.Romana law of vector addition, so the resultant of these two vectors EB and EA is given by diagonal of the parallelogram. That is, it will be horizontal, parallel to the length of the dipole, and it will be along BA. Then EA and EB can be resolved into rectangular components. Now EB will be EB cos theta and EB cos theta and EB sin theta. Similarly EA cos theta, EA sin theta. So from figure, after resolving EB and EA into their rectangular components, we see EB sin theta and EA sin theta are equal and opposite. Why? Because EB magnitude, in this case, EB magnitude is equal to EA magnitude. Because magnitude charge is same and BP is equal to AP. In this case, BP is equal to AP. Point P lies at same distance, at equal distance from both points A and B. So EB magnitude is equal to EA magnitude. So therefore, EB sin theta and EA sin theta, they are equal and opposite. So they will not contribute to electric field at along pi axis. So it means they cancel each other's effect. So that is, in the y direction, EB sin theta and EA sin theta being equal and opposite, they will cancel each other's effect. So the components EA cos theta and EB cos theta, they are added. So it means resultant field at P will be equal to E is equal to EB cos theta magnitude plus EA cos theta. But EB magnitude is equal to EA magnitude, so we can write E is equal to 2 EB cos theta or 2 EA cos theta. 2 EB cos theta or 2 EA cos theta. And direction of resultant electric field will be from B to A. That is, from positive charge to negative charge, perpendicular to the equatorial line. It means electric field due to dipole at a point on the equatorial line is opposite to the direction of the dipole moment. Dipole moment always acts from negative to positive charge in this direction along the length of dipole. But electric field due to dipole at a point on the equatorial line is opposite to the direction of the dipole moment. So both magnitude and direction we have calculated. Or E is equal to 2, what is EB again? Same formula, 1 upon 4 pi epsilon naught. Distance charge over distance square Q upon BP square into cos theta. Cos theta, this implies E is equal to 2 1 upon 4 pi epsilon naught Q BP square means R square plus L square, R square plus L square, square root whole square, because BP is under root R square plus L square, square root. And what is cos theta? Cos theta is from this right angle triangle OBP, perpendicular over hypotenuse, L upon under root R square plus L square. I will simplify. So this square root cancels. So E comes out to be 1 upon 4 pi epsilon naught 2 QL 2QL is again written as P. So P upon R square plus L square power 3 by 2. Which is the required expression for electric field due to dipole at a point on the equatorial line. E is equal to 1 upon 4 pi epsilon naught P upon R square plus L square power 3 by 2, because this square root cancels square. So R square plus L square power 1 comes from here, 1 by 2 from this square root. Total power is R square plus L square 3 by 2. And again, when L square is less than R square for a short dipole, so E will be equal to L square can be neglected as compared to R square. So E will be equal to 1 upon 4 pi epsilon naught P over R cube. This is electric field due to dipole at a point on equatorial line. You can write EE for equatorial line. This is EA for point on the axial line. Just to differentiate EA. So resultant field due to dipole at a point on axial line and resultant field due to dipole at a point on the equatorial line. So again, it proves that electric field due to dipole at a point on equatorial line is inversely proportional to cube of the distance from center. But it decreases more rapidly as we move away from the center of the dipole, just like electric field dipole at a point on the axial line. But one thing we can notice that if R is same, that is electric field due to dipole at a point on equatorial line is half of the electric field due to dipole at a point on the axial line. So it is 2p upon r cube axial line, 2p upon r cube at a point on equatorial line is p upon r cube. It means electric field due to dipole at a point on the equatorial line, E is equal to half EA, or EA is equal to 2EE. That is electric field due to dipole at a point on axial line for the same distance from center of dipole is equal to twice the electric field due to dipole at a point on the equatorial line. So this is all about electric field due to dipole at a point on axial line or at a point on the equatorial line. So ਤੁਸੀਂ ਇਹਨੂੰ ਇੱਕ ਵਾਰੀ ਫੇਰ ਰੀਵਾइंड करके देख सकते हो, और दोनों आर्टिकल बहुत इंपॉर्टेंट है एग्जाम ਦੇ ਵਿੱਚ। यू मे बी आस्क्ड find expression for electric field due to dipole at a point on the equatorial line, or find expression for electric field due to dipole at a point on the axial line, and how electric field due to dipole at a point on the axial line and equatorial line related to each other for the same distance r. So EE is equal to half EA, or EA is equal to twice EE. So be happy. Next video I will discuss torque on a dipole and potential energy of a dipole. So I have divided this electric field and dipole into three different parts so that you can understand easily, or video should not be much longer. So thank you so much. Be happy. ਜੇ ਤੁਹਾਨੂੰ ਟੀਚਿੰਗ ਵਧੀਆ ਲੱਗਦੀ ਹੈ ਤੇ ਮੇਰੇ ਨਾਲ ਜੁੜੋ, ਔਰ ਵੱਧ ਤੋਂ ਵੱਧ ਆਪਣੇ ਸਟੂਡੈਂਟਸ ਨੂੰ 9th to 12th ਜਿਹੜੇ ਤੁਹਾਡੇ ਦੋਸਤ ਨੇ ਜਾਣ ਪਛਾਣ ਦੇ ਨੇ ਉਹਨੂੰ ਮੇਰੇ ਨਾਲ ਜੋੜ ਕੇ ਮੇਰਾ ਚੈਨਲ ਸਬਸਕ੍ਰਾਈਬ ਕਰੋ ਤੇ ਫ੍ਰੀ ਆਫ ਕਾਸਟ ਘਰੇ ਬੈਠੇ ਫਿਜ਼ਿਕਸ ਸਟੱਡੀ ਕਰੋ।